So, wow.
Wow. Wow.
So, line integrals in vector fields. An important application of line integrals is finding, as I said before, work done when moving an object over a force field along some curve C. An example of an object in an inverse square field might be figuring out how much power is needed to launch a rocket into space, recalling that gravity is an inverse square field, or beyond the gravity pull of the Earth. The farther from Earth, the less is required to move the rocket. So a line integral along its path might be able to find the necessary fuel load for the rocket launch. Think about a force field F and consider an object moving along a path C in the field. To calculate the work, one needs only to consider the work done by the force in the same direction as the curve, or in the opposite direction of it if it's opposed. Therefore, at each point on the curve, you need only to consider the projection of the field F onto a unit vector in the direction of the curve, call it T, of the vector value function, describing the curve. Like I say, that sometimes is the hard part. How do you make that vector value function? So on a small subarc of length del SI, the incremental amount of work done for moving along that subarc is delta Wi, where delta Wi is force times distance, and that times, if you're dealing with vectors, is in fact the dot product. So it's f of x I, y I, z I, the force at that particular spot, times a unit vector in the direction that that force is being asked to move in, times our del SI, and that would be times what would be associated with the length of that subarc. So the total work done moving along a curve C and the force field F is given by the integral. Okay, here it is. Work done is the line integral along curve C of f of x, y, z, that's the force field itself, dotted with a unit vector in the direction that the thing is moving. So f and t are both vector valued functions, so this product is a dot product. This line integral appears in other applications, and the basis for the definition of the line integral is the basis of the definition of a line integral of a vector field, or we could say in a vector field, line integral in a vector field along a curve, or something like that. So we can make it look a little different if we mess with it. We can say it's force field dot unit vector times ds, so force field dot unit vector in the direction of motion dot ds, which is, recall, that was the length of r prime of t dt. So that's from the definition of line integral. This is a unit tangent vector in the direction where we're looking at. And all this stuff goes to show we could write this as f times dr.
Yes, indeed.